Alright, welcome. Today's Tuesday, March 24th. It is a review day for Unit 9. We have a few people already in the chat. Go ahead and go to your Kahoot.it and type in this code. We will get started with a streamed Kahoot game. Let's turn on the music. Can you hear me now? Let me change the volume. I can't. Can you hear me now? Might be a little better. Yeah. Okay. This is gonna be weird if we only have like a few people. I'm hoping we can get like 8 or 10 at least. The Kahoot music is still louder. Okay. Good morning. How come all of you, well, I only have 5. Let's see, Giorgio, Christian, Maddie, Dennis, and Bryant. I guess that's all we got today. Where is Speedy Cat? Speedy Cat, go ahead and join us, whoever you are. And it's Sarah Garcia. Sarah, go ahead and log into Kahoot. Casey, you should be in here. Hurry up, Casey. Okay. While you guys set up here, actually, I'm gonna go and lower this a bit more. Actually, turn off the music for now. There we go. While everyone loads up, I'm going to update our canvas. It will update or upload the review. You can of course get the review from zPhysics, but I will put it on our canvas right now. Basically, we're gonna play Kahoot today. Work on the Unit 9 review worksheet. Small online participatory quiz-like activity. There we go. Tomorrow. Playing Kahoot today, working on the Unit 9 review worksheet. Small online participatory quiz-like activity tomorrow. Ooh, we got Nicholas, Alyssa, that's probably Alyssa G from period 5. Welcome. Nicholas, alright, and then that's 8. Let's see if we can get 2 more, that'll be cool. Alright, so let me upload our worksheet and we can see it on Canvas or get it from zphysics.net. Review worksheet. Oops. Files. Okay. I will turn on the music, I suppose. Wow, we hit 10 already. Excellent. Alright, so if you go to the 324 section, you can get the Unit 9 review worksheet. After we play Kahoot, we'll just go over a few things from there, and then take some Q&A stuff. If you have questions, you can ask me. So that'll be great. All right. Chat. When should we start it? How many people should we wait for? This. Tardguard. Who is Tardguard? That's a new one. Vanessa is always sleeping. She was sleepy in the morning, even when school was in session. Now that school is off session, I'm pretty sure she sleeps in super late. You want to wait for 12 people? Alright. We're at 11 right now. 20? I don't know if we can get 20. Unless you guys tell everyone. Yeah. Whoa, our viewer numbers are jumping up, so that's pretty cool. Alright, so make sure you go to Canvas to download your... No, I don't think we'll ever hit 150. She gets up at like 8:30. I suppose. I highly doubt it. I'm gonna guess somewhere around 10 o'clock. She gets up around 10. We're at 11, so one more for the dozen. 9:52. What? 18. What are you typing, Maddie? Leo the physics dog stepped on some glass at the park yesterday. Ouch. Ouch. That is not fun. Yeah. So let's get one more person, whoever shows up. I may need to cut the video or something, do something. Should we do some practice problems while we wait? Let's take a look. I texted Duyan, but didn't respond. Duyan is not up, huh? Alright. So that's the review worksheet. And there's a bunch of... So the first page, or first page and a half, is all review. So you can quickly review all the stuff. There's just notes. And then we start with the conceptual questions. Use your PowerPoint, use the book. And then we have a few review problems, and the answers are given. Alright. Okay, still waiting on one more. Good morning, the homie Nasaka. Sorry, my dog is trying to get my attention and she stepped all over my laptop. Oh, that's the weird numbers and stuff. I don't know if we can hit 12. I think we're hitting our limit here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I mean, we have more people in chat than actually on Kahoot. You are in chat. We have bots? Oh gosh. No, I mean, I can actually, as a streamer, I can actually see who is logging in, so. And there are more viewers than actual people who logged in. Alright, I don't think we're going to get more than... Oh, there it is. There's the 12th person. Very good. It was Casey no, this is Casey's second account. I'm a bot. I'm so tired. Casey made a second. Well, thank you, Casey. Let's go ahead and get started. I wonder if this is how it works. Okay. Wow, it says the direction of electric field lines shows the what? Waiting for that last person, Casey number 2. Hurry up and answer. Oh no. We kind of split off there between red and green, it seems. Yeah, the electric field lines show the direction of a force on a positive test charge. My dog dropped my yogurt on the floor. Maddie, your dog is just not behaving today. Strength of the field. No, that's not how you see the strength of the field. Okay, so the delay is quite noticeable now. Oh. Is it? It's probably like 3 seconds. I think the delay is 3 seconds. Yeah, so basically you have to answer when the clock hits 3. Otherwise, otherwise you might see that there's 2 seconds left, but the timer actually already ended, right? So make sure you hit the button before 3 seconds. All right, so there you have it. It is the direct. This is how we mapped it out. Remember, we used a little tiny positive test charge. We moved it around our charge in question, and then we saw which way the force would be. That's why when you're near a positive charge, the test charge will be pushed away from a positive charge. And of course, if you had a negative charge, the test charge will be pulled towards the negative charge. All right, that was just a warm up. I mean, is it a Monday? No, it's not a Monday. It's a Tuesday. That's all right. Every day is a Monday. Here we go. Alyssa G in the lead. Excellent, Alyssa. With Nicholas right behind her, and then Dennis third, Reed, and Eric. Right. There we go. Eric Zeladita probably is in the house. Eric, if you're in chat, where's your buddy Andrew Rosas? I haven't seen him in a while. I'm not sure if he's watching our streams or watching the VODs. This is, why does a balloon stick to a wall after you rub it in your hair? Ah, you guys remember this trick? I showed it to you in class. Even though the wall is neutral. Uh-oh, I gave it away. Or did I? The wall is neutral. That is a true statement. But remember, we are polarizing the atoms inside the wall, which means we can push the electrons at the front of the wall to the back of the atom, which makes the front side of the atoms positive, and therefore the negative balloon will attract to the front side of the wall. The delay is like 10 seconds. What? Why? Let's see. Settings. Stream. You cannot change these settings when you are live. Oh man. Bitrate, audio. I don't know how to change it. Streamlabs OBS delay setting. How do I fix it? Anyone know how to fix that? That sounds really inconvenient, so let's see. Low latency mode on Twitch. Any streamers in chat can help us? It's okay, I'll just leave and rejoin. I don't know if that'll fix it. It's the stream and internet itself from Mr. Z. There's a low latency mode on our end. Yeah, so do low latency mode if you can. I don't know if I can do it on my end. But where is that, Dennis? Where do you see low latency mode? We're running into technical difficulties today. Under settings, advanced. Under settings and then advanced. Okay. Alright, should we, did that fix it, or did that work, Dennis? Are you on a PC or mobile? Where settings at? Uh-oh. Did that do anything, Dennis? Can you confirm if that is working or not? Let's go and change the slide. Boom. Alyssa still in the lead. Well done, Alyssa. Are you on PC or mobile phone? Then I'm not sure. Well, it should be on low latency mode. We got a new follower, Otter. Excellent. That is our 100th follower. Wireless high five to Otter. Thank you for being the 100th follower. Whoa. I don't believe that option is available on mobile. That is quite unfortunate. Well, okay. I will look into it after this stream if I can do anything on my end, but I don't think I changed anything. I just re-logged in today, that's all. Alright, here we go. Question number 3. What happens to the gravitational and electric force if you triple the distance? Hint, instead of r, it's 3r now. But make sure you remember what the formula is. Remember what is at the bottom of the formula for both gravity and the electric force. No, I think we have extra players because we're over 12 people now. Yes, we do. Very good. If you triple the distance, remember the r is squared. We're not doing very well today. But remember, there's a r squared in the denominator. So instead of plugging in r, you would plug in 3r. And if you square the 3r, you get 9r squared. Yep, so it's a 9th. So there's a 9 in the denominator. Even with low latency mode, there's still about a 6-second delay on my end. Please refrain from spamming caps. Giorgio. Yeah, it's r squared. R squared. Yep. Let's see who's gonna take this. Alyssa G still in the lead. Kuya Casey coming up right behind her, and Christian Tran is in the top 3 now. Well done, Christian Tran. The low latency doesn't work. So it's about 10 seconds ish. That is quite unfortunate. You're not doing so hot today. Yeah, I don't know. That just means that you gotta study up, review, do the review, download the review worksheet, start reading it. All right, here we go. You gotta hurry on this one. The time's gonna end. Yep. The only difference is that remember you can have positive or negative charges, and of course likes repel, opposites attract. There you go. Yeah, you want to give yourself like 5 or 10 seconds. 5 or 10 seconds. Our viewer count is going up. That's really cool. Make sure you join us. Even if you're late, go ahead and join us. Play. See how many points you get. Never know. There we go. Alright. Alyssa's still in the lead. Nicholas has come back to 2nd place. Dennis in 3rd. Okay. And Eric in the top 5 now. Well done, Eric. Here we go. Okay. Remember, the rod is not touching the conductor, it's just near it. It's right next to it. This is a phenomenon that we've seen. It starts with the letter P. P as in pony. Wow. Time is running out. You have like 10 seconds. Ooh, all right. So this is called polarization. If you take a look at the charging by polarization notes, when you bring the rod close to the conductor, a negative rod, this will push the electrons to the backside. And so if you make contact on the backside, those electrons will jump off, which means the conductor becomes positive. So the conductor is negative and then it turns positive. No, the conductor is neutral. We just push the electrons to one side. The whole thing is still neutral. It's just the front side is positive, the back side is negative. However, when you touch it, you allow the electrons to jump off. When the electrons do jump off, then it actually becomes positive charge because it lost electrons. Okay. Yeah, the electrons move to the other side, and then when you make contact, when you touch it, it jumps onto your finger, and so the conductor itself will become a little bit more positive instead of neutral. Yes, the electrons go to you and into the ground. Alright, let's see. Alyssa's still in the lead. Good job, Alyssa. Adam Zane. Good job, Adam Zane, coming up. The highest climber. Wow, that delay is nasty. Yeah. See if low latency mode works for you. It dropped Dennis's delay to like 6 seconds. Alright, good job, Adam Zane. But Dennis is now in 5th place. Good job, Dennis. Alright, let's see. Remember, you want to hit by, I guess, 10 seconds when the clock says 10. You don't really need a calculator, because everything is in proportion. We just did a problem like this. Yeah, time's up. Well, we want to answer by 10. So, yes, if you double the distance, you get 1/4, 1/4, because the 2 gets squared. And so 1/4 of 8 is 2. That's all it is. 1/4 of 8. How's the delay on that one? When did it run out? I think maybe it's getting better. I don't know. My bit rate seems fine. We shall see. Alyssa is on fire. No one can stop her. Christian is now in second place with Nick and Adam already up to 4th place. Well done, Adam. Mine ran out right when it ended on stream. It is nasty. Oh, really? DRZ, you're 14 seconds. My voice start complaining low. So DRZ321 says he's pretty much on time. Yeah. Well, let's keep going. Just try your best. Make sure you give yourself some bank time at the end. So don't wait until the time is up. Okay. How does a rod become positively charged if only electrons can move? All right. Let's see. Who do we? Wow, we have 10 people who got it. Electrons are taken off the rod. Very good. Remember, you become positive charge by losing your negativity. You become a positive person. So positive charge. All the positives are from your protons, of course, but the protons are stuck inside the nucleus of the atom. And so as the electrons move around, if you lose electrons, you become positive. If you gain electrons, you become negative. What a glow up I'm having. What, a glow up? What is a glow up? I don't know what that is. If you can explain, go ahead. Here we go. Giorgio, all right, Giorgio now in 4th place. Reed Campbell in 5th. Good job. I forgot, I didn't see that last time. There we go. So Nicholas, Adam, Giorgio, Reed, Alyssa still in the lead. Good job, Alyssa. There we go. Question 8. Watch the board. All right. There's an electric field runs between two oppositely charged parallel metal plates. Okay, this is literally what we were talking about yesterday. You actually have multiple drawings of this in your Flippy book. Alright, straight lines evenly spaced. That is what we call a uniform electric field. A uniform electric field. This is a model to represent what the field looks like. So we draw vectors, arrows. Those arrows are away from the positive and towards the negative plate. This is the same model we use to illustrate the gravitational field near the surface of the Earth. Remember, near the surface, if you zoom in, the Earth is actually flat. So for that small space near the surface of the Earth, we can say that the gravitational field is nice and constant. Yep. So most of you got that. Very good. All right, Adam Zane in second, Giorgio in third, Reed and Nicholas. Ooh. All right, Mr. Z, an actual glow up is where, like, okay. All right, well, let's keep it PG in here. Okay. Think about extending the radius. Extending the radius. Oh, time's almost up. Alright, well, this is not good. This just means that we just straight up guessed. So let us actually take notes on this. Let's see how we can figure this one out. Going to our OneNote. Oh, there we go. That is not our OneNote. Uh-oh. Oh. What happened? Hmm. Wow, everything is just not working today. Well, let's see. So why is it inverse square? Okay, so remember, force decreases as r increases. Force decreases as r increases. So if you have a force versus displacement graph or distance graph, you have F in the y-axis, and let me see if I can just use paint. Yeah, I can. Okay. Ooh. So if I have force on the y-axis and r on the x-axis, so this is force in newtons, r, which is our displacement in the x-axis. Okay, we know that F's the equation is F kqq over r squared. I'm not even going to try. In any case, as r increases, the force will drop off, kind of like a slip and slide. Instead of a straight line, it'll be like a curvy exponential decay graph. Okay, because the r is squared, and it's going to drop off even faster than a regular 1 over r. Right? The options that you had were straight line, straight horizontal line. If you had a straight horizontal line, that means the force is always the same no matter how far you are, so that can't be right. The second one is straight line with positive slope. That would tell you that as r increases, as you get further and further away, the force actually gets stronger. That is definitely not possible. Remember, when you're further away, it's weaker. And finally, straight line with negative slope. That one's a close second in that, yes, it does decrease, but it's not linearly decreasing. It is exponentially decreasing. So it has to be the other one. Okay, an inverse quadratic. A regular quadratic would be, like a parabola. It increases upwards. An inverse quadratic is 1 over r squared. I thought it was straight negative. Nah, it is 1 over r squared, so it can't be straight negative. It decreases, not with a negative slope, but it decreases as an exponential decay curve. It goes downwards really quickly instead of linearly. Alright, so let's see. Nothing changed at the top, but Nicholas, Adam, Giorgio, and Reed are in the top 5. Yep. Okay, you better answer in the next 10 seconds. Well, that's just a conceptual question. Two charged particles have forces that increase. Once you let go of them, they must have opposite signs. So why would the force increase? Well, that's because they're probably going to get closer together. And so if they're closer together, then the force, as you attract each other, the force will increase. And you would only attract each other if they're opposite charges. Yeah, that's a purely conceptual question. All right. There we go. Alyssa's on fire again. 7 correct answers in a row. Holy moly. Is anyone going to catch her? I don't know. E force, just another way of saying the electric force. You have like 5 seconds probably. Yep. So if you double each charge, you get 2 times 2, which is 4 in the top. So you have, instead of Q and Q, you would have 2Q and 2Q. That gives you 4QQ or 4Q squared, whatever it is. And so it's quadruple, 4 times bigger. How do I move down? The shape in the Kahoot thing is the answer. Circle. Yes, circle is the answer. All right. We got Reed, Giorgio, Bryant in 3rd place. Good job, Bryant. Keep it up, Chapito. Nicholas in 2nd, and we have Alyssa still at the top. All right, that's a freebie. If you don't know this one, that means you haven't done your mastering physics all this time. Oh my gosh, we did it. We got 100. Can we get 100 in the chat? Let's do 100 hype train. I am slowly becoming a Twitch streamer. Yes. 100%. Okay. All right. Now let's do something slightly more challenging. Boom. $100. Good job, Kuya, Casey. Hint, what do forces do? Oh, we were so close. We were so close. Accelerate away from each. Yes, I mean, there's a force of repulsion, right? It's a force. The force is equal to ma. Remember, forces apply acceleration onto an object. Or, sorry, I should say forces accelerate objects based on their mass. And acceleration means it is not moving at constant speed. So they will accelerate away from each other. Not 100. But it's still good. 80%. I'll take it. Ooh, Adam Zane is on fire. Alyssa's still on fire. Or probably still. And then we have Nicholas, Giorgio. Giorgio's back on the list. Reed is in 5th. What is that frog face? 80%. The sad. It says Derek Fields. Ugh. How do you get those emotes? I wonder how we can make our own. I want to make our own physics emote. That would be cool. Or emoji, whatever they're called. Oh, by the way, we just hit affiliate. Oh, we are now Twitch affiliates. I wonder what that means. Ah, I see. Gifted subs. We are now affiliates, so I think you can do like emojis and stuff now. Is that how it works? Let's see. I'll find out today. If you charge a neutral rod to plus 1,000 coulombs by rubbing a cloth, the cloth will have a net charge of negative. Yes, how do you think we got that 1,000 coulomb of charge? Well, by losing all of those electrons. And so where did those electrons go? Of course, into the other material the other material absorbed or accepted all of the extra electrons, becoming negatively charged. You can start making bank. Oh wow, I didn't know that would. Did I pick the volts? I wasn't looking. I'm so pressed. Oh, you picked negative 1000 volts. Ah, it's charges in coulombs, not volts. Remember, volts we use for potential, and yeah. Mr. Z, what's your Patreon? I don't have a Patreon. I'm just a physics teacher. That's all I am. No, keep your money. Maybe when I stream video games or something, I'll become a real Twitch streamer. But right now we're just a teacher Twitch streamer. We're looking into some of my old students who have graduated a couple of years ago. They're like my first year at Alco. They want to get together and do like a League of Legends game or something, and I think I'll stream that. Alright, let's finish this up. We're almost done. Uh-oh, Nicholas is getting closer to Alyssa. Come on, Alyssa, keep going. TikTok live. Legal. Yeah, I know. Alright, let's see. Every potion... Oh, no. Every proton in the universe is surrounded by its own... I know, I said potion. What am I thinking? Got video games in my mind. I just got an email for the affiliate stuff. Adam was right. Adam knows all about it, apparently. Oh no, this one did not go well. We now have a wizard. You're a wizard, Harry. This did not go well. What happened? Uh-oh. Okay, let's go back to our handy dandy, smart board. Let's see, what is our smart board? Here's our smart board. It's called Microsoft Paint. Forgot gravity exists. Yeah, remember there's this thing called gravity? So if you had a proton... Oh, this is... I don't know what I'm doing. There we go. Ooh, this is the warping of the space-time fabric. Remember, when you have something called mass, it distorts the space-time fabric. It dimples it like a trampoline. So protons do have mass. They're not light. Get it? Light. Light doesn't have mass. But they do bend the space-time fabric around it. So of course, a proton, not only does it have an electric field that points away in all direction. Whoa, whoa, whoa. But it also has the gravitational effect in that it bends the space around it, similar to any object with mass, like a star or a black hole. How can we walk and not... and what? We should make a physics TikTok. Yeah, maybe we'll do like a TikTok challenge or something as an assignment. How's that? No. We'll figure it out. And then you have to kind of like do something physicsy at home to make like a little quick TikTok video, and then we'll see if we can share it live, and then we'll make like a collage of it, and this can go onto our physics music video that we have at the end of the year. Yes, indeed. All right. So yes, gravity exists. Very good. We learned something very important today. Even protons, which have mass, have a gravitational field around it as well. All right. Okay. Alyssa's still in the lead. Is Alyssa still here? I don't know. I think she just parked it, and she might still win it. Alyssa, if you're here, type in chat. Yeah, I don't use it too, so we might have to find a platform that everyone uses. This is similar to a question we talked about, trying to find where the forces can cancel each other out. Aha! So we have two equal plus charges are separated by d where, well, if you have two plus charges, remember at the middle, you have 0 electric field. And so if you put anything there, since the field is 0, charge times field, recall that the equation is F is equal to Q times E. So if E is 0 in the middle, that means the force must be 0 in the middle. The usage of TikTok is inexcusable. You spelled it wrong. I wonder what song we would do. Alright, anyway, F equals QE. Since E in the middle is 0, then the force must be 0. There we go. Alyssa is back. She is here somewhere. Last question. We are almost done. We're almost done. How does one increase potential energy? What do you have to do to increase your potential? The square fitting perfectly into the corner is so satisfying. Ah, yes. Oh my goodness. Let's go through the answer choices. The force is greater. That is a true statement, but doesn't answer this question. Positive charges repel each other. That is another true statement that does not answer the question. And that is probably why everyone chose all of the above. Just because something is true doesn't mean it actually answers the question. This is actually something that happens all the time, everywhere. So be careful. It happens in the media as well. Just because something is true doesn't mean you're actually answering the question. To increase your potential energy, you have to do work. You do work by applying a force over some distance d, and force times distance gives you that work. Of course, our force is not constant, so we can't technically use force times d here, but that's okay. We can actually calculate the potential energy difference between the final and original positions. Recall that potential energy, electric potential energy, PEE, is equal to KQQ over single R, not R squared, but single R. That gives you the energy. I bet there's a Quizlet with all the answers. I agree that there is a Quizlet for this. Probably. This is kind of old. I've been using it for like 3 years now, so I'm sure there's a Quizlet on this by now. Alright, let's take a look. Reed in third place. Good job, Reed Campbell. Nicholas in second. All right, Nicholas. And of course, Alyssa G taking the gold medal. Oh, runners up. Adam Zane in fourth and Giorgio in fifth. All right, let's go. All right. Cool, cool, cool. All right, so go to your Canvas. There's a really cool study guide, study worksheet that you should look at. We're going to go ahead and try a quiz-like activity tomorrow. A quiz-like activity will open up at midnight tonight, but you'll have a whole day. Let me turn off the music. I can't. Uh-oh. Well, there's one way to turn it off. And so make sure you look through the study guide. We'll do a quiz-like activity. Do your best on it. And then when we actually come back to school, probably in like May and stuff, we'll start taking, our exams, our culminating exam experience. But for now, we're just going to have small quizzes. I am on the desktop. Oh, thank you. And as you can see, I also used a tiny little logo on the bottom left. I'm figuring out how to do overlays and stuff. All right, so I suppose that is all. Thank you for watching.